Hi there, this is Penelope. This is a short video on decimal numbers as part of a series of short videos on revision of arithmetic skills. So we're going to look at decimal numbers, and if one integer is divided by another integer, and that integer is not one of the first one's factors, we won't get an integer as an answer. Our answer will be somewhere between two integers, maybe. Let's have a look. Let's have a look at 25 divided by 8. Now, if you do that on your calculator, it's 3.125, which is somewhere between 3 and 4. It's not an integer. Now, like integers, though, we could put that on a number line. And 3.125 is in there. Okay, that's fine. We would also know that 3.125 would be 3 units plus 1/10 plus 2 hundredths plus 5 thousandths, or it's 3 plus 1/10 plus 2 hundredths plus 5 thousandths. So we know all that, and that the decimal point is between the units and the tenths. So it's between 3 and 1/10. So numbers like this are called decimal numbers. All the operations of arithmetic that we've used with integers apply to decimal numbers, but when performing a calculation involving a decimal number, often the answer is a number with a large quantity of numerals after the decimal point. For example, let's have a look at 8.92 into 15.11, or 15.11 divided by 8.92. Now, if we do that on the calculator, we're going to get something that looks like 1.69394618883. which is a fair mouthful, and often that's way more accurate than we need it to be. So to make such numbers more manageable or more reasonable, we can round them either to a specific number of significant figures or to a specified number of decimal places. So let's have a look at significant figures first up. And significant figures are counted from the first non-zero number starting from the left. So if we look at, say, 9.4534, and we want to write it to two significant figures, we start here, 1, 2, and look at the third one. So one more than we need. So look at the next one. Is the next one 5 or more? The answer in this case, yes, it is. It's 5. So the answer then would be 9.5, because we're going to round up. So if it's more than halfway, we round up. Have a look at 0.001354 and take that to two significant figures. Okay, so we want to look at the first two non-zero digits starting from the left. So 1, 2. Now look at the third. The third is 5, which is greater than halfway, so we need to round it up. So the answer would be 0.0014. have a look at, what could we look at? 2.235 to 4 significant figures. So 1, 2, 3, 4. Look at the fifth one. The fifth one is bigger than 5. Well, it's 5. So we round up. So it would be 12.24. Have a look at 3.465, and let's do that to 3 significant figures. So that's 1, 2, 3. So now we need to say, well, that needs to be we need to look at the fourth one. 1, 2, 3. Look at the fourth one. It's 5 or more, so this one needs to be raised up. 3.47. Now, decimal places are not counted from the beginning, they are counted from the beginning of the decimal point, so that the number of digits or number of numerals to the right of the decimal point. Okay, so let's have a look at 1, 2, 3.4467, and let's go to 1 decimal place. So that's this one. Now look at the next one. So that's 1. Look at the next one, it's 4, so we would leave it as 123.4. Let's take it to 2 decimal places. So that's 1, 2. Look at the third. That's going to push that one up, so it becomes 123.45. So we're looking at raising it if it's 5 or more, or rounding it if it's 5 or more, just like the same way as we do with money. Sometimes some zeros must be put in to kind of get it right. So if we want, for example, 1, 2, 6, 4, 5 to 2 significant figures, and 1, 2, so we look at the third one, then we need to raise that one, and then all of these ones have to become zeros, if you like, so it would become 1, 3, 0, 0, 0. 13.1 to 3 decimal places would be, well, there aren't any at the moment, there's only one, so we'd have to put them in like that. So these zeros and these zeros are referred to as trailing zeros. They're zeros we have to put in to kind of make it right. A fraction is an integer divided by another. So in order to put it into a decimal form, all we have to do is do the division. So 7 over 4, for example, is 7 divided by 4, which we can do as a division sum, 4s into 7. And we can either do it on our calculator or do it by long division and get 1.75. We could do 3 over 8. Now 3 over 8 is 3 divided by 8, which you could do on your calculator and find that it's 0.375. But what you're doing is 8 into 3, like that. Then we can go the other way. A decimal can be represented by a fraction. So if we have something like 1.224, okay, to get rid of the decimal places, we'd have to go 1, 2, 3. So 1, 2, 2, 4, and put it over a 1 with 3 zeros. Right, so we had to move the decimal place 1, 2, 3. So we're going to put 1, 2, 3 zeros there, and if we're going to simplify that, it would be 153 over 125. 0.52. Okay, that's 52. So go 1, 2. That's 2 over 2 zeros, so 100. And if we simplify that, it would be 13 over 20. Sometimes we get odd answers. Sometimes we get a number that has no sort of cutoff. It doesn't stop. It just repeats infinitely. For example, 1 over 3. If you do that division, it's 1 divided by 3, and you end up with 0.3333333 forever. It doesn't stop. It's an infinite, that the number is an infinite or unending list of 3s. So what we do for that case, to shortcut that, is we write 0.3 and a dot over the 3 that shows that the 3 is repeating. Now, it becomes a little more tricky when you've got a pattern repeating. So there's a pattern. The 135 repeats, so that you'd put a... Oops, no, look at it more carefully. Actually, it's just the 35 that repeats. So we'd need a dot over the 3 and 5 to show the beginning and the end of the bit that repeats. Have a look at the next one. The next one, the 908, repeats. So you'd have a dot over the 9 and a dot over the 8, a dot over the 9 and a dot over the 8, to show you that it's the 908 that repeats, not just the 9. You don't put a dot over all of them unless it's like that, where it's just 2 of them repeating. But for this one, you don't write it as 0.908 ... You don't write it like that. There is some textbooks that write it like that. I'd prefer it if you wrote a 9 and the 8 with a dot, but some textbooks write it like that, but definitely not like that.